Okay, so if we look at section 9.1, sequences and series, if I look at example 1, I'm asked to find my first 4 terms of the sequence a sub n equals 3n minus 2. And so to find your first 4 terms, you're just going to plug in the numbers 1 through 4 into your equation. So if I go to find my first term, if I plug in 1, then I get 3 times 1 minus 2. 3 times 1 is 3, 3 minus 2 is 1. So my first term is 1. If I go to find my second term, 3 times 2 minus 2. 3 times 2 is 6, 6 minus 2 is 4. If I find my third term, I plug in 3 for n, so 3 times 3 minus 2. 3 times 3 is 9, 9 minus 2 is 7. And then lastly, if I want to find my fourth term, 3 times 4 minus 2. 3 times 4 is 12, 12 minus 2 is 10. Does that make sense how you find your terms? Everybody did really well on that on your pre-test. Yes, do you want me to go over them the second one? Or does that make sense, finding your terms? Just plug numbers in, 1 through 4. Alright, so I'll skip that one then. And we'll look at the nth term, because that seemed to be what threw people off the most. And it will get easier, but for today we're going to find our nth term by guess and check. Okay, so this is my first term, second term, third term, fourth term, and it helps if you write the terms above the numbers, because then you'll know what you're starting with and what you're trying to end with. Okay, so your top row is the numbers that you're starting with. Bottom row is the numbers that you end with. Okay. And so like I said, we can use guess and check, so we can try to solve it using multiplication or division. We can try to solve it using adding or subtracting, or we can do a combination of both. Okay, and I'm going to start at the back and work my way forward, because pretty much anything you do to 1, you're going to end up with 1. Okay. So if I look at 4, I need to figure out what I need to multiply or divide 4 by to turn it into 7. If I start with multiplying and dividing. So 4 times some number equals 7. And as we know, there's not a whole number that you can multiply 4 by to make it 7. So we know that multiplying or dividing is not going to work. If I then go to adding and subtracting, I need to start with 4 and end with 7. And so I know that I'm going to need to add what to 4 to make it 7? 3. Okay, so I know that works for this one, so then you work your way backwards to check the rest of your terms. So if I check 3, 3 plus 3 is supposed to equal 5. Does 3 plus 3 equal 5? No. So I know adding and subtracting doesn't work. So then I know that I'm going to try a combination of both and see if I can find some combination of adding and subtracting and some combination of multiplying and dividing that works. Go away. Okay. So I'm starting with 4. I need to multiply by something and either add or subtract something from that to get it to be 7. Okay, and so the closest thing that I can get 4 to be 7 is to make 4 into 8. So if I multiply by 2, then I get 4 equals 8. So then to change that to 7, I know that I need to subtract 1 from that. So I'm going to try the pattern of multiplying by 2 and then subtracting 1 to see if that works. So if I work backwards and check 3, does 3 times 2 minus 1 equal 5? Yep. Okay. So if I check 2, does 2 times 2 minus 1 equal 3? Okay. And lastly, 1 times 2 minus 1 equals 1. Is that true? Yeah. Okay, so I know my pattern is times 2 minus 1. So that tells me that then my nth term, a sub n, is going to equal 2 times n, whatever my n value is, minus 1. Alright, so you guys want to do another one like that? Yes, no, maybe so, yes, okay. Alright, so then if I look at my next sequence, 2, negative 5, 10, negative 17. And then I label my terms 1, 2, 3, and 4. I know that I'm starting with these numbers, and then I need to get to end with the other numbers. Okay, for now I'm going to ignore my negatives, because it's an alternating negative sequence, so some numbers are positive, and then the opposite with negatives. I'm going to ignore those for now. So I know that I can try multiplying or dividing. I know that I can try adding or subtracting, or I know that I can try both. Okay, so if I start with 4, 4 times something has to give me 17. Is there any whole number that I can multiply 4 by to make 17? No. Okay, so if I look at adding 4 plus something to give me 17, so if I add 13, then that works. So then if I check with working backwards, 3 plus 13 then supposedly is going to give me 10. Does that work? No. So then I move on to both. So I know I'm going to start with 4. I'm going to need to multiply by some number and then add or subtract some number to make it be 17. So the closest number that I can get to be 17 is if I take 4 times 4 and then add 1 to that. Because 4 times 4 gives me 16, and then plus 1. So I'm going to try the pattern of times 4 plus 1. So if I then plug in 3, 3 times 4 plus 1 does not give me 10, gives me 13. Okay, so I note that these two numbers are the same though, so I'm going to try a different pattern. 3 times 3 plus 1, and see if multiplying the number by itself will give me the pattern. So does 3 times 3 plus 1 give me 10? Yes. Okay, so then if that's the case, then that would mean that then I have to take 2 times 2 plus 1, which gives me 5. And 1 times 1 plus 1, which gives me 2. Okay, which is what I wanted. So I know that my pattern is n times n plus 1, where I'm taking the n's times themselves and then adding 1. So I know my sequence then is a sub n equals n squared plus 1, as n times n is n squared. But I also know that I was ignoring my negatives until this point. And so whenever you have negatives in your sequence, you know you have negative 1 to the nth power as part of your sequence. So whenever they alternate negatives, then also include that part at the end. Why?
Because you
doing opposite ends, then do n plus 1, and then it makes it work. Go away. Like that. So n plus 1, and then your second terms will always be negative, and your first terms will always be positive. Okay, then the second part of what we did was factorials. And so hopefully you've seen factorials before, but if not, then we're going to look at them today, which is where you just multiply the numbers leading up to your n by each other. So n factorial would be 1 times 2 times 3 times 4, etc., till you get up to times n. And then the only exception to that rule is 0 factorial. 0 factorial equals 1. So So if I'm going to simplify factorial expressions, if I'm given 8 factorial divided by 2 factorial, 6 factorial, I'm going to expand those in order to simplify. So I know 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Doesn't matter if you write it in the other order, but whichever order you write it means the same thing. 2 factorial is 2 times 1. And 6 factorial, 6 times 5 times 4 times 3 times 2 times 1. Okay, so I'm going to cancel the things that are the same. So I can cancel my 2's and I can cancel my 1's. Then I can also cancel 3's, 4's, 5's, and 6's. So then what I'm left with on top is 8 times 7. What I'm left with on bottom is 2 times 1. So 8 times 7 is 56. 2 times 1 is 2. 56 divided by 2 is 28. You guys want to do another one like that? No? Okay, makes sense. Okay. So then lastly, what we looked at was summations. And we've looked at limits of sums, but we've never looked at just the sums by themselves. So that's what we're going to look at today. So a summation symbol just tells you to add up your terms up until your ending term. Okay, so this is the number you start with. It won't always be 1. Sometimes it'll be 0. Sometimes it'll be a different number. This is the number you end with. And you plug those numbers in and then add your terms. Okay. So if I look at example 7, I'm given the sum from I equals 1 to 5 of 3i. And so I know that I'm going to start at 1 and end at 5. And I'm going to plug all those numbers in. So if I plug in 1 for I, then I get 3 times 1. And then I know I need to add my next term to that. So then if I plug in 2, I get 3 times 2. If I plug in 3, I get 3 times 3. If I plug in 4, I get 3 times 4. And if I plug in 5, I get 3 times 5. And I'm stopping at 5 because that was my ending value. So then if I figure out what that is, 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. Okay. So then all of those add up to 45. So your sum is 45. Okay, you guys want to do one more like that? No? Makes sense? Okay. Alright, so you guys are working through 647, 9 through 35 odd, 47 through 52, 71 through 74, 77 through 80, 85 through 90.